Hello and welcome to Short Circuiting. This is a quick one. There's not honestly an awful lot to it. Here's the general idea behind short circuiting. So if we have a Boolean expression like true and true. Okay, so obviously that's true. True and false. That's false because both of them would need to be true. Same thing with ORs. So if we do like true or true, totally fine. True or false, also totally fine. False or false is false. Okay, so from a just Boolean logic standpoint, this is how this works. Questions so far? Cool. So JavaScript does a fairly unique thing where when it evaluates these, it doesn't actually coerce them to Booleans. So if we do truthy and falsy things instead, where we end up with like, instead of true and true, if it's some string and some other string, that doesn't actually evaluate to true the way that this does. What it does is it evaluates to some string, which is truthy. So I can use this like in an if statement or anywhere that I would use a Boolean expression and get the same thing. But it doesn't actually change the data type. Or actually, no, this would some string and some other string would evaluate to some other string. Because it would need both of those to be true. So it looks at this one and goes, OK, awesome. And then it checks this one and goes, OK, cool. All right, this whole thing is truthy. But it's really just that is truthy. And so if I tried, I don't know, saving that into something or passing it into something, that's what it ends up evaluating to. That's a curious behavior. And it allows us to do some kind of interesting things. So like a really common one with ands is what we call preconditions. So I need something to be true, and if it is, I want to call a function, say. So that might be something like is enabled and initialize. That would be exactly the same as writing if is enabled then initialize. It doesn't like give us anything that we can't do with if statements, but that is way more concise than the equivalent if statement. So in the process of trying to figure out if both of these things are truthy, it looks at both of them. So it goes, all right, if that's truthy, okay, it is, so we keep going. If it's not, it doesn't even look at the next part of the statement. It goes, all right, well, if that's false or falsy, I'm not going to waste my time checking the rest of it. But if that's truthy, all right, well, what about initialize? Well, it's going to actually end up calling this function in an effort to like figure out whether or not that's truthy. So that's why that is a shorthand for this. If that's true, all right, is the next part true? Well, it just ends up calling the function. That's false, doesn't end up calling the function. That's a short circuit. It's another condensed way to do an if statement. The one with ors. So this, so like we use ands and short circuits mostly with preconditions. This needs to be true before this gets called. Ors we tend to do with defaults. So it might be something like const color equals some color or red. Like if this isn't a function, that takes in some color. So if that has a truthy value, well, we don't need to evaluate the rest of this or statement because only one of these things needs to be truthy for the or. So if this has a value, awesome. That's what ends up getting assigned to color. Not the truthiness or falsiness of this entire statement, but this actual value. If that's not set, it goes, all right, well, what about the other side of this? Oh, this string red. So that gets assigned. It's exactly like doing something like let color if not some color equals red. Just like the one with ands. It's just a different way of writing this if statement, and it's a lot tighter. Those are called short circuit evaluations. We want a precondition. We want something to be true before we call a function or something. We want to give something a default. Ask me questions about short circuits.
So like, was that an intended behavior, or
Yep.
it just happened to do that? Okay.
Yep, it's the design. Most languages don't do this, but JavaScript does. It's pretty cool.
What's a practical use that you could see something like this being used?
Oh, I use it all over the place for these two things. Giving something a default value that can be overridden, or doing a precondition. So like, hold on, if I look through my code base, I promise you I'll find some. I do them all over the place. So I'm going to grep. Grep stands for G replace. Don't worry about what the G stands for. But grepping is a CLI way to search through files for like a particular string. So I want to grep for some place where I'm doing, I'm going to do ors first. Some place where I'm doing an or inside the current directory. Ooh, that's a lot of. Let's do it inside of source. There we go. Yeah, all of these are default evaluations. So like if I go to this app content one. Okay, so this one is a great example. When I make anchor links in the LMS, there's two different ways they can look. So, oh shoot, actually, no, this one's just a regular Boolean. Let me find a different one. All right, that one's even better. This is in Curriculum Viewer. Okay, so I'm passing in this user ID. If I'm logged in already, I want it to be my email. If I'm not logged in for whatever reason, I don't want it to be null. I don't want it to be undefined. Something will break if I do that. It needs to be some string. So I default it to an empty string. So if this comes back falsy because it's not set, then it short circuits to an empty string. That guarantees that this thing will always have a string type. It's either an email address or it's an empty string, but it's not null, it's not undefined. Could be, stop it. Let's find another one. Perfect, this one, use indicator. So this determines which, whether you get a red X or a green check mark or something like that. This is a short circuit where if it says accepted, it does that one. If it says rejected, it does that one. If it doesn't say anything, it short circuits into pending. Because it never, a submission never gets pending assigned to it. It's a default. So I could do it that way. The alternative, doing it with if statements, would be if indicators at status return, or no, it's if there's a status, then return indicators at status. Otherwise, return indicators at pending. Oops, even got rid of it. This and this are the exact same thing. I like this because it's more concise. It also sort of explains my intention with this a little bit better than I think the equivalent if statement does. I have to do a lot of reading to understand why that works or what I'm trying to do with it. This one, I want to look up a key in the indicators thing. If I have a status already, use that. Otherwise, default it to pending. I have to think a lot harder if I'm reading that one. Sharon, does that answer your question?
That makes it a whole lot more clear.
Good. I'm glad. I'm not sure if I have an example of and short circuiting in here. It's less common, but I might. Let's take a look. Change something there. Oops. There we go. Okay. Oh, never mind. I totally do. Authenticated routes. Okay, this is a good example of and short circuiting. The app error component, which, hey, we should all recognize that one at this point. It's hey, look familiar? So it renders that if there's an error and we're not loading, then make that show up. So that's two preconditions. If this is true and this is true, then it should be that. And in React in particular, like this syntax probably looks insane because it's half JavaScript, half HTML. It's a language called JSX. You're not allowed to use if statements in JSX. They have to be expressions. It's the only thing you can do. So the way that you get that done is with short circuiting. Angular is a little bit more forgiving, lucky for all of us. But if you can't use conditionals, use short circuits instead.
How does it know that its error is true, right? Like, how does it know if it's true or false?
It came in from this other file.
Oh, okay.
So like when something throws an error, it uses some part of this app to tick that flag and sets it to true. And so the overall,
Yeah.
Go ahead.
So the is error,
Yeah.
that and is not loading. And I guess because the last one, the app error, is in the brackets, is that what it stands for, that it has to equal to, or?
No, so what it's saying is it's like I copy and pasted all of this HTML over here. That's what app error is. It's just that HTML. So what I'm saying is if that's true, like is error equals true. If that's true, then it's going to keep looking because everything in an and statement needs to be true for it to evaluate to true. So it goes, all right, well, that's true. How about is loading? And since I have a not on that, is an error and is not loading. Okay, well, that is not loading. So both of those are true, but I have another and statement. And all three of them need to be truthy for this to evaluate to true. But here's the secret. I don't care if the whole thing evaluates to true. What I want is if both of those things are true, to short circuit so that that's what I end up getting, which is just this HTML. Preconditions. If both of those things are true, I want that to show up.
So it's like the third thing's built on a house of cards, and when they
Yes.
fall,
Yes.
that triggers the event to happen.
Bingo. And that could be a function call. That could be all kinds of different things. But it's the equivalent of saying if is error and not is loading, render this. All of that is that one line. Super like condensed, tight way to write conditional logic.
That also an example of the hoisting, since it's above the rest of it.
No, I'm making this probably a little confusing. These are just to illustrate.
Oh, okay.
The idea here, although like, hey, great vocab. Hoisting would be like this function that I just declared here. If I called it here, I haven't actually defined it yet, but the declaration hoists. And so it's available from the beginning of the file on. That's hoisting. So like the important things that you need to know about short circuiting are, and short circuits are for defaults. Use this, or if it's falsy, use this other thing. And short circuits are for preconditions. Before you do this, make sure that this and this are true.
What about like the double question mark one?
Nullish coalescing. Nullish coalescing does the same thing as an OR short circuit, but it doesn't do any falsy values. It literally only does null or undefined. Here's the problem that nullish coalescing was trying to solve. It's a really rare case, but can totally happen. Where like you have something where you have a falsy value, but it's not an empty value. It's something like something was set to false, like if I'm like a subscriber or something, and I'm trying to think of a good example of this. Be like, is subscribed or shoot, that's not it. Let me pull up an example. It's the exact same thing as an or, but instead of going if it's any falsy value and checking the other one, it only checks the other one if the first one was null or undefined. Null-ish coalescing example. Yeah, here you go. This is a good one. So if that's null or undefined, then we get our short circuit default. If it's something like 0, it doesn't. Because even though 0 is falsy, it's not null or undefined, so it doesn't short circuit. And that's actually a better example, I think, than the true or false. It's something where you want it to be 0, and like 0 is a meaningful value, but it also might be empty. So think about like a bank account where you're like, okay, if this person doesn't have a bank account, start them with one that's worth $100. If they have a 0 bank account and you do that short circuit, it's going to go, oh, that's a falsy value. Let me set you up with $100. I was like, no. You have an account. It just has a 0 balance. It's way less common. Like if I were to rank these, it's like or short circuits by a mile, and then down here and short circuits, like you do them, they're just a little less common. And then all the way down here, nullist coalescing. Giving something a default, making sure that a precondition has been met before you do something. Giving something a default, and you got to be careful about the value that you're short circuiting, because you might need to use a falsy value as like a real thing. That's short circuiting. What questions do you have about it? So to recap, OR and nullist coalescing are for defaults, and is for preconditions. Short circuiting works because when JavaScript evaluates a Boolean expression with like truthy and falsy values, it doesn't evaluate those to a Boolean. It evaluates them to whatever their actual values are. That's kind of a hack that lets us do condensed conditional statements. There's nothing you can do with a short circuit that you can't also do with an if statement. It just is often more clear than using an if statement. It's almost always more concise. And sometimes your intent comes through a little bit more using a short circuit instead of a conditional. Cool. Hopefully that helps.